Welcome to day 7. First thing we should be doing is taking out our homework. So it is ready to go. Number 2, you should be writing down your homework for tonight. We got packet page 58, putting that in your planner. And then 3, giving the warm-up a try. So we're going to pause the video for 2 minutes for you to have those 3 things done. So to have your homework out, to have the homework written in your planner, and to do the warm-up. If you're unsure of the warm-up, flip back a couple pages before the homework to see that idea of what a z-score is. All right, so z-score, your z-score value just tells you how many standard deviations you are above or below the mean. So if we get a data value whose z-score is 1, that just means our data value is 1 standard deviation above the mean. If you had gotten -1 for your z-score, it means the standard deviation is 1 below the mean, 1 standard deviation below the mean. So it's just telling you the number of standard deviations either above or below the mean. All right, flipping over to your homework. So just a recap of where we put these in. We do menu, statistics, distributions, and then norm CDF. First number is our lower bound, then our upper bound, then they go in alphabetical order for the last 2, mean and standard deviation. So when you're doing each of these on your paper, I would suggest to draw the picture for them. So I'm going to draw an example of the picture for letter A. So we've got our normal curve. We want it greater than 16. So draw in roughly where 16 would be. And then because we want it greater, we're going to shade to the right of it. So then for our shaded region, the lower bound is at 16. And if you go up forever, we said we were just going to use some big number, we would use +5 nines. If you went down forever, we said we would use -5 nines, just to pick some either really big positive value or really big negative value. And then once we got that, we had to switch it to a percent and round it to the nearest tenth. So we ended up getting 50.0% for that one. And you can check each of your percentages for the other one. The work that must be shown for like a test, the regions, on your homework, anything like that, you've got to write out that command in the calculator, that norm CDF, and then what each of those values were that were put in. So we'll take about 30 seconds and just give you a chance to check each of those. All right, next one. So we wanted between 5.2. 5.2 is less than the mean. 7.6 is above. We wanted between. So we eventually got our norm CDF there, put that in. But notice they didn't want the percent. They wanted to know how many cats. So we had to take that percent as a decimal, multiply it by the total of 128, and then that would give us our number of cats. So one extra step from what we had to do on the last one. We want less than 58 ounces. 58 is below the mean, so just draw a random line somewhere below the mean. We want less than that, so we're shading in this part here. Lower bound, we're going forever to the left, so we'll just use that -5 nines. And then our upper bound is 58. put in your mean and standard deviation, and this time they just wanted the percent. So move it over twice, switch it to a percent. And then for number 4, we want it above 90 degrees, so 90 is above the mean. Shade in above, so 90 is the lower bound. Positive 5/9 are used for the upper bound because it goes up forever. You got your mean and standard deviation. But they didn't want the percent or the probability, so we had to take that decimal and multiply it by the total number of days, which was 31. So in the end, we got 2.07, so the best choice there was 2. All right, we're going to flip to packet page 53, and we need to also have our calculators out. So we're going to pause the video for 1 minute to make sure you're on packet page 53 and have your calculators out. All right, our first thing for today will allow us to review what we did last class, but with one slight twist. So we're going to look at questions that ask for a percentile. A percentile refers to the percent that is left of the data value. So right here, percentile rank refers to the area, or in other words, the probability that is left of that value. Now, where you guys have maybe seen percentile in your lives is when you get your score back for the SAT. Say on the math section, it says you scored in the 74th percentile. What that means is you scored better than or equal to 74% of the people who took that test on the math. So it's telling you who you were better than or equal to. That's what your percentile is. So it's the area to the left on the curve. So if we go down to the next example, so we've got the average weight of full-grown beef cows is 1,470 pounds. They give us our standard deviation of 230 pounds. We want to know what is the percentile rank of a cow that weighs 1,750 pounds. So for these, remember, always draw your normal curve. We've got 1,750 pounds, that's above the mean, so let's draw a random line somewhere above where the mean is and label it 1,750. Now on the homework, when we had a single value, it just came out and said the percent that was below that or the percent that was above that. But this time they want the percentile, and it's up to us to know that that's the percent that's less than the data point. So if it asks for a percentile, it's looking for the percent that is less than. So because we're going forever to the left, remember we're always just going to use negative and 5/9 for that lower bound, just to show something that goes really, really far to the left. And we'll go ahead and put this in the calculator. So just a recap, we've got menu, statistics, distributions, and then norm CDF. Our left bound was that negative 5/9. Our upper bound, we had the 1,750. And our mean is going to be the 1470. And the standard deviation will be 230. Tab, I think, is the easiest, going between them, right above the control button. And again, this command here with the norm CDF, that is the work that we need to show on our paper. So we had the norm CDF, we had the negative 5/9, the 1750, our mean of 1470, and our standard deviation of 230. We got 0.888272 unchanged. I imagine this calculator, this was on float 6, so I'm going to change it to float. I notice now when I put it in, it should match with what you probably had on your calculator. You had more decimal places. All right, so now we want to find the percent, so we'll move it over twice. That's 88.82 and change percent. And to the nearest percent, we're getting 89%, so that matches with choice 1. So most of this is the same as what we did last class. The one new thing is the knowledge that if it asks for percentile, you're finding the percent that is below. All right, so if we go to the next example, 16-year-old teenage boys, they're normally distributed their heights with a mean of 66 inches and a standard deviation of 3 inches. Jabari's 72 inches tall, and which is closest to his percentile rank? So when we see percentile, it wants to click in our head, we're finding the percent below. So we'll draw that normal curve. Jabari's height is above the mean, so we'll put a random line above the mean and label it 72. Percentile means percent below, so we'll shade to the left. And we're going to pause the video for 1 minute for you to put this all in your calculator and see which percentile is best. If you're stuck on the button presses, okay, menu, statistics, distributions, norm, CDF, and ask someone around to help you out. All right, we had norm CDF, -5/9 for the lower bound, 72 for the upper. Our mean is 66 and standard deviation of 3. That gives us 0.9772. Switch to a percent, that's 97.72 and change percent. So to the nearest percent, we've got 98%, so the 98th percentile. So that's one new element for today. Again, most of the process is exactly the same as we did last class, just the knowledge that percentile means the percent below. We're going to skip the next example, and we're going to move to where it says practice problem 1. So we'll give you a moment to flip in your packets there. Should just be one turn of the page at most. So in general here, we want to examine how big are soldiers' heads. So the Army reported that the distribution of head circumference for male soldiers is approximately normal with a mean of 22.8 inches, standard deviation of 1.1 inches. We want to know what is the head circumference that would place a soldier in the bottom 24% of head circumference. This question is different from what we saw so far in this class and last class, in that it gives us the percentage. And the thing we want to find is the data value. So it reverses it. Before, we always knew the data value. We wanted to find some percentage. Now we know the percentage, and we want to work backwards and find the data value. So how do we do that? Well, let's draw our picture to start out. If you're in the bottom 24%, you're in the lower half. So let's draw a random vertical line somewhere in the lower half. And let's put a question mark on that vertical line because we do not know what that data value is. The bottom 24%, so that would be the percent to the left of it. And that's all we need filled in our picture. Now, we're going to show you how to do this on the calculator. The way the calculator is programmed, you have to always put in the percent to the left as a decimal of your data value, even if they gave you what was above. So for example, if we knew that this was like 10% up here, really what we would end up putting in our calculator is 90% as a decimal. And it's just because the way the calculator's programmed, you always put in the amount to the left of the data value when you're finding the data value and know the percent. So, well, where do we go for this? So we're going to go menu, statistics, distributions again. But the last one is what changes. We're going to do the inverse normal. Like when you're solving equations, you always do inverse operations. You go the reverse operation, you undo it. Well, we've been doing norm CDF. If we want to go the reverse direction now, we're going to do the inverse normal. So we'll select inverse normal. For the first box area, it needs to be the percent to the left of the data value, but as a decimal. So for us, left of the data value is 24%. As a decimal, that would be 0.24. So we'll put that in for the area. And then the next two are just like we've seen before, mean and standard deviation. In this case, we've got 22.8 for our mean and 1.1 for our standard deviation. So we'll hit tab to get there. Just like before, this is what it shows up as is your work you need to show. So we'll have our inverse norm. We've got the 0.24, that percent as a decimal to the left. We've got our mean 22.8, and then 1.1 for the standard deviation. So we get 22.023. And they want to the nearest tenth. Well, that 2 in the hundredths place has us keep the tenths the same. So we'll have 22.0, and our units in this is inches. Now, just a little rounding bit of information. If they're asking to the nearest tenth, you need to have a number in the tenths spot. Even if it's going to be a 0, something has to hold that spot if they want it rounded to the nearest tenth. All right, part B, same mean, same standard deviation, but we want the top 15% head circumference. So we'll draw our curve. Top 15%, that data value would be on the upper end. So let's put an vertical line on the upper end and put a question mark. It's the top 15%, so to the right of it is 15%. Well, that's great, but when we put it in the calculator, we're going to have to put it in as the percentage that's to the left of the data value always. That's just how the calculator is programmed. So we need to think about, okay, if there's 15 to the right, what would be the left of it? And they've got it together, add to 100%. So 100 minus 15 would give us 85% over here. So when we go to put in that first box in the inverse norm, it's going to be 0.85 because that's the percent that is to the left of the data value. Now, one thing you can do if the mean and standard deviation are actually staying the same, if you want, rather than hitting all our buttons, you can scroll up and select inverse norm, okay? And you get those just by going ups and downs. So if you go up twice, highlight it, hit enter, and bring it down, then you can just scroll over and change the 0.24 to 0.85. If you didn't want to do that, you could still do your menu, statistics, distributions, and number 3, the inverse normal. But this is just a way if your mean and standard deviation aren't changing, how it can be a little quicker. Okay, so we'll hit enter there. We got 23.940. Write that down before I forget it. We got to have our work as well. Remember, we had 0.85. Comma 22.8, comma 1.1. And we want to the nearest tenth. So the 4 keeps the 9 the same. So we have 23.9 inches for that head circumference. So the key thing when going in reverse is when you put it in the calculator, you have to put the percent that's to the left of your data value. We are going to skip the next question and go where it says practice problem 3. And what we're going to do is we're going to do each of these. We're going to have you do it on your own, but we're going to have you do one. We'll go over it and then do the other. So we are going to pause the video for 3 minutes, we'll say, and see if you can do this first one, and then we'll play it, make sure you're in good shape, and then we'll pause it again for part B. Okay, so go ahead and do part A now. All right, so we should have drawn our normal curve. Top 30%, so we'd want to line somewhere on the top half, put a question mark. Top 30%, so that means 30% is to the right of it. But when we put it in the calculator, we're going to have to put in the percent to the left. So 100% minus 30% gives us 70% on the left of it. So do your menu, statistics, distribution, inverse norm. That first box will be the 0.70, which is the percent that was to the left of it. Then your mean of 15 and standard deviation of 3. And when you put that in, then round the nearest tenth, we get 16.6 pounds. And I guess I'm making the assumption that it is pounds. It never specifically said that, but it's probably most likely pounds. All right, this time we are going to pause the video for only 2 minutes for you to do the next one. All right, so draw your curve. We wanted the bottom 10%, so put that data value line somewhere on the bottom part. Bottom 10%, so that'd be 10% to the left of it. That's what we want when we put it in the calculator, so nothing extra we have to do. So you got 0.10 for that first number, 15.3, you get 11.2 for the weight. All right, the last two we are going to do together, C and D. So if we got 15 rhesus monkeys randomly selected, how many will weigh less than 12 pounds? Well, notice here, they did not give us a percent. When they don't give you a percent, it's like we did yesterday or last class and at the start of this video. So we want to find the percentage. Well, 12 pounds is what they gave us. That's less than our mean. So let's put a line somewhere to the left and label it 12. We want to label less than 12 pounds, so we'll shade this in. Our lower bound, remember, we'll just use -5/9 if it's going forever to the left. Just to recap, remember our mean and standard deviation were 15 and 3. So we are going to go menu, statistics, sorry, not stat calculations, menu, statistics, distributions. And we're back to norm CDF now because we're trying to find that percentage. We're doing -5/9. We had 12 for our upper bound. And then we had 15 and 3 for the mean and standard deviation. So we're getting 0.1586 or so. We've got to make sure to write down our work, our norm CDF. And that again gave us 0.1586 and change. Well, this is like the 2 questions from the homework that had an extra step. Notice it didn't actually want the percent. We want to know how many of the monkeys. So we just got to multiply this decimal all the way out, by the way, times the 50 total monkeys. So down here, if we just do times, it'll automatically do the answer. So times 15, we get 7.93 monkeys. And to the nearest whole, we would have 8 monkeys. All right, and last one, What percent of the monkeys have a weight that is greater than 20 pounds? Notice we want to find the percent, so this is like the ones from last class, not the new ones for today. So we'll draw our picture. 20 was bigger than our mean. We want the percent that is greater than 20 pounds, so we'll shade that way, meaning our upper bound is just 5/9. So we'll go to the calculator, we'll have menu, statistics, distributions, norm CDF. Our lower bound based on our picture is 20 with the upper bound of 5/9. We've got our mean of 15, standard deviation of 3. So we got 0.0477 or so. So we've got to make sure to write down our work. Norm CDF, we had the 20, the 5/9, mean of 15, standard deviation of 3. We got 0.0477 and change. Switch it to a percent, we'll have 4.77 and change percent by moving the decimal over twice. And then to the nearest tenth of a percent, the 7 here bumps the 7 in the tenths place up to 8, so 4.8%. Alrighty, that is it for this video. Any time left in the period, you can work on your homework. Have a great rest of your day.